In this video, we will look at the end behavior of the graph of a polynomial. We have four cases. Case one is that we have an odd degree and a positive leading coefficient. If you have an odd degree and a positive leading coefficient, then the graph of f eventually falls to the left and rises to the right. It doesn't matter what it's doing in here where we have the three dots. We're just looking at what the end behavior is doing to the left and the right. So falls to the left and rises to the right tells you that you have an odd degree and a positive leading coefficient. Case two is if you have an odd degree and a negative leading coefficient. If that's the case, then the graph of f eventually rises to the left and falls to the right. Again, it doesn't matter what's going on where these three dots are. We're just looking at the end behavior to the left and to the right. Case three is if you have an even degree and a positive leading coefficient. If that's the case, the graph of f eventually rises to the left and rises to the right. A good example of this would be parabolas, which you are used to seeing at this point. So if you have a degree 2, that would be an even degree, and a positive leading coefficient, you would have an upwards facing parabola. But that rule really works for any even degree, like 2, 4, 6, 8. If you have an even degree and a negative leading coefficient, the graph will fall to the left and fall to the right. So even degrees have the endpoints either both pointing up or both pointing down, and odd degrees have the endpoints going opposite directions, up and down. And if you have a positive leading coefficient, it'll be down to the left, up to the right. Negative leading coefficient, up to the left, down to the right. Let's look at some examples here. We want to choose the end behavior of the graph of each polynomial. So our first one is f of x equals negative 5 x to the 7th minus 2x squared plus 3. So let's look at our leading term first. So this is our leading term, and our degree is 7. So degree is the highest exponent. So degree in this case is 7, which is odd. And our leading coefficient is negative. I don't even care that it's a 5, I just care about the sign on there. So the leading coefficient is a negative 5. And so really, what I'm doing is I'm matching up odd degree, negative leading coefficient. And let's scroll up and look at our options here. Odd degree, negative leading coefficient. Our graph will be rising to the left and falling to the right. So it rises to the left and falls to the right. Now you could try to graph this. You could graph it in Desmos. Sometimes you have to adjust the window a lot in order to see the full graph, but you could do that in Desmos and then just zoom out till you see the whole graph. So rises to the left, falls to the right. So it'll do something like this. I don't know what it's going to do in there. It could have little squiggles, maximums and minimums. And then on the right, it'll eventually go down like that. All right, this next one, f of x equals 9x squared minus 5. I'm sorry, f of x equals 9x squared times the quantity 5 minus 4x quantity to the 6th power. So what I care about is the leading term of this polynomial. So I don't care about the whole polynomial. I don't want to like multiply everything out, but I want to think about what the leading term would be. The leading term, I have that 9x squared. And then the leading term of this 6th power part over here is going to be the leading term of the linear factor raised to the 6th power. So the leading term for that 5 minus 4x quantity to the 6th power would be negative 4x to the 6th power. So notice I'm just taking the leading term of the linear factor and raising it to what power I have on the outside of the parentheses. Okay, so let me just figure out really quick what that would be. I'm going to go to the Desmos calculator. And I want the scientific calculator for Desmos. So I want to do negative 4 to the 6th power. And I know it will come out as a positive because it's to an even power. Let's see, to the 6th power, 4,096. I'm going to multiply that by 9. So I get 36,864. So I have 36,864 x, add the exponents because I have the same base of x. So 2 plus 6 is 8. So this is the leading term. And so I have a positive leading coefficient. And I have an even degree. And so I know that it's going to rise to the left. And it's also going to rise to the right. So it'll go like that. I don't know what's going to happen in there. Could have lots of local maxima and minima. But what I do know is the ends will eventually go up in both directions. Notice I did not try to multiply this whole thing out. All I did was I looked at the leading term within the parentheses and raise it to that power. And then I had to multiply by any other factors that I had as well. So use this chart and figure out the end behavior by looking at the degree, whether the degree is odd or even, and whether the leading coefficient is positive or negative.